Hello, this is David Braun, and I wanted to introduce some of you to the TLeaves valuation processor. Now, I've been in the business a long, long time, and I'm really excited about some of the new automated features and equipment that appraisers have available to them now. One of the big ones is, of course, the measurement of the house using your cell phone and walking through the house. That's just wonderful. For me, probably the biggest thing we ever did was the on-street navigation systems. I used to use the fold-out maps, and I would drive, and every few blocks I'd have to refresh looking at my map and making sure I could get to the right place. And I always had the joke, if I could find it, I could appraise it. I didn't always find it. And in the early days when I started, we didn't have cell phones. And when I couldn't find it, I would actually sometimes have to drive back to town 4 or 5 miles to find a payphone to call to get better directions. In those days, you learned to get really good directions on the phone. But I want to talk to you about part of the process of valuing, the actual valuation process. Not a lot has been done. Now, I have been studying analysis for appraisers actually since the year 2000. I presented at the Appraisal Institute meeting at the year 2000, I believe in Las Vegas, and I demonstrated a automated valuation model or for appraisers. So I've been doing this for a long time. The last 5 years, I've been intensely doing it. I wrote a book, The Valuation Analyst, and in that book, I basically prove that it's a fallacy for us to go out and try to extract adjustment rates. It's just not real. And showed mathematically that in some situations, using one pair of sales will often lead you to the wrong answer more often than the correct answer. So what I've been looking for is another way for appraisers to not only get a good answer and get a repeatable answer, but also a way that they can still show that the report is worthy of belief. So what we're going to look at here, and I'm going to start by, this is in Excel, this runs in Excel. I'm going to start by clicking some worksheets, and I'm going to show you what the report would look like in the Excel print viewer. You can get an idea. This is, see, the TLeaves valuation processor. This is an education version 5.7.423. All right, and then here would be the first page. And then here's the page that has your outputs. Now, this is not all filled in the comments, but this is kind of what it would look like. And then this is the page that you enter your data on. So it shows your information, and you'll see all of the property characteristics are in numeric form so that the computer can help you find your values, and they are in a ranking system. And then this is the sales grid. This grid is not like the Fannie Mae grid, the second, or Freddie Mac grid, and the secondary, basically the secondary market grid. But this grid is quite legal if you're doing work for individuals, divorce, if you're doing work for estates, those kinds of things. There's no requirement on what type of form you use. So you could actually use this if you wanted to. You could just take these numbers over into your other form. But for right now, we just want to get something automated for appraisers. Now, this talks a little bit about the market condition rate and gives some charts. And then this is basically your evidence here. The model quality indicators are your evidence that your adjustments are appropriate. Right now, the way that you have credible adjustment rates is to demonstrate that you use good data, you used a recognized adjustment extraction technique, and you performed it properly. That's what we do now. And a lot of times you'll have to analyze if you do if you make four different types of adjustments, you have to do four different analysis. And it just takes a long time. And like I said, if you read my book, you'll see that it's kind of a fallacy to do it that way anyway. So these market quality indicators indicate how well that your adjustment rates worked in trying to find the value. And then we have a last page that is definitions. I'm not going to go over these. You can freeze this video and read these if you'd like to. But that's what basically we're looking at. Now today what I'm trying to do is today I'm trying to see if we can measure how accurate the TLeaves processor is. So I've gone to a sheet called the trainer, and this is what you train with, and this has also helped me to develop it. And in this case, I have some data here, and basically we're finding, I think, 5 property characteristics. Those are what I call our active variables, and that's condition, quality, gross living area. See, the ones with 0 we're not doing. The garage, we're not. Location would be a passive variable because we don't have to make that adjustment. And actual age, and then but over here we have baths. So that's our 5: baths, garage, gross living area, quality, and condition. And these ratings up here we have set with the rand between function. Our condition rating, for example, can be anywhere from 3 to 5. Quality 3 to 5, our gross living area from 1,600 square feet to 2,000. Our garage can be anywhere from 2 to 3, and we'll just go ahead and make that maybe 2 to 4. And then our bath can be anywhere, this says 4 and 8, but it actually ends up being between 2 and 4 baths. So anywhere between 2 and 4 baths. Now, when I hit the random button here, these will change, so I don't have to change these by hand every time. Now, what we want to see is if we vary the sales prices randomly by a plus or minus 4%, how well will this TLeaves help predict? Now, here is the intrinsic value. For example, right now, this one, the real value of the sales price should have been $462,980. But when we varied the sales price plus or minus 4%, it actually, what we see is a sales price of $449,091. The same difference here. This one should have sold for $514,820. But when it scrambled, then what we see is $504,524. So these are scrambled each time. Now, what I want to do now is I want to hit the transfer button because remember, this is a market maker and it's a trainer sheet. You really won't use this after you learn it, but it helps us to judge some things because it's going to tell us how accurately it predicted for these numbers. So for example, right now our sales price is $408,140. So we'll say the subject price is $408,000, will be close enough. Now I'm going to hit the transfer. This is where you would normally load your data. That data that we made in the trainer module came over automatically. So now we can hit to load. And now we're getting ready to run the processor. But this is a place where you have a chance to, as the appraiser, to influence the valuation processor, because this works with augmented intelligence. It's not designed for you to rely on it by itself. It wants the appraiser to be involved. So you could put some anywhere there's a question mark. These are active variables that are going to need adjustments. Where there's NA like location, they were all the same, so it didn't matter. So you could put numbers in here, but we're not going to use any numbers except we have to have a land to value ratio of 18%. So now we'll just run the processor. And what we want to do is keep a chart, and we'll run it 10 times and see how accurately it predicts with using 5 comparable sales and 5 variables that need adjustment rates or property characteristics. And with the sales prices scrambled randomly between a plus or minus 4%. Now this will take somewhere around a minute to a minute and a half to run. So we'll let this run, and then we'll record some information. And as you know, it may take longer here because of the old saying that a watch pot never boils. All right, it took 51 seconds. All right, we'll click this. And now I want to make a couple notes here. One is this is the mean absolute percentage error for the comparables. That is when your adjustment rates were applied to the comps as if they were the subject property, it shows how close they came. For example, this price, the actual price was $449,000. There was a prediction of $460,000, so it was 2.4% residual. So I'm going to write down 1.74%. All right, and I also want to make sure there's no red here. If there's red here, we want to be aware that we might get a bad answer, but there's no red over here in any of these. And obviously this quick video is not something that's going to teach you this information. We'll have to have a seminar or a kind of a webinar Zoom meeting to go over more of these details for those who are interested. So there's no red, so I'm going to mark no in the red. Now we go to our trainer, and we can see that the answer was the 408. That's the correct answer. Now, the TLeaves got 402, so basically we were 1.5% off. So I'm going to write that down, a 1.5% error, and that's with drift. And again, we'll have to talk more about drift later. Without drift, we would have been 0.51%. Not even 1% off. You see 402 to 404. Now also this has built in a attribute scoring system, and when we forecasted the value based on composite utility scores, we got 407,000 for our answer. So this is an error from this one down here. You can look at the 407 against the 408, it's very close. But we were about a minus 0.74%. Now, what I'm going to do, and so I'll show you what happened here then. So this automatically put these adjustment rates in that it found. These are the adjustment rates for quality right here, condition, gross living area. It used 12,007 for the bath. 16,600 for the parking, and then it came down here with an indicated value, and I believe it's set to automatically do the weights based on the amount of adjustments. And then at this point you would have the ability, if you were really using this, then to make changes here. You could change these, and there is a model monitoring system that's built in. When I turn that on, now it gives you more information and it would help you make an adjustment. Now I'm just going to do one real quickly, because the point of this is not to teach how to use this. It's to show how accurate it is under a specific situation. So I've clicked on the parking amount, and the valuation, the processor used 16,600. I think maybe that's too high, so I'm going to hit the MMS setup. You see this line comes across, it kind of helps you know you're in it. I'm going to type in 14,000. Okay, then I'm going to hit enter, and then I'm going to look for the summary, and it says that basically our indicators that were over on this sheet, and we'll flip back over in a second, that most of them got worse. So in this case, I don't want to make that adjustment. I'm going to hit the go back and set it back to the 16,600. Now I would turn this off, and we see our indicators in, which is our evidence that our adjustments are right. Here, there's 6 of them that you would have to learn. So let's get back now to the trainer. So we've recorded everything. So let's do this 10 times. So I'm going to hit the random and scramble this a few times. And now it's got a different price that we're going to be looking for is the 441. This is left in from the last time. So when it reruns, it'll reset these. So I'm going to hit the transfer, the load and pre-calcs. And again, I'm not going to help it here. I could help the processor, like with where I thought that parking was high. I could limit the parking. I could put from 8 to 12,000 and force it to find that. And then I'm going to hit run the processor for our second run. And keep in mind that what we are using here, the processor is relying on, is the Excel solver. And down at the bottom, you can see some numbers running, and it's trying to find the best adjustment rates that it can. So I'm going to show you this one more time, and then I'll pause it and finish up and show you our results. So let's see what we get here. Okay, in this case, it took 1 minute and 1 second, so about a minute. All right, so let's take our notes here. I'm going to see that our mean absolute percentage error, our MAPE, is 1.52%. There's no red, so I'm going to put no. And then I'm going to come to the trainer. And we had predicted 443 on the adjustment grid. The actual answer was 441. So you see we got a very, very close answer. 0.33%, which is very good, not even 1% off. And without drift, it would be 0.53. So probably what you'd want to focus on without understanding the drift is just this one, the 0.33. So how good did our attribute scoring system did? It's a little higher, it's a little farther off. It got 450 in this case. So it got 450, so it is off minus 2.28%. So I'm going to stop here and go ahead and run another 8 of these. I finished running all 10 scenarios. Here are the runs, 1 through 10. And remember, we kept a record of if any of our property characteristics were so different from the comps. If the subject was different from the comps, there would be red, and we only had one that had a red. So in the end, this is probably an insignificant characteristic that we measured here, but I didn't know, so I thought I'd go ahead and get it in. The MAPEs, you can see here, were like for the first run, it was 1.74. This is the mean average, the mean absolute percentage error for the comparables. So let's see what our average would have been, equals average. All right, enter, and let's make this a little bit bigger. And let's just drag this over so we can see all of them. So actually, it had a good MAPE. The average error was extremely good. It was less than 1%. The error 2, which unless you're a researcher or a data scientist, you probably don't care about this, but error 2 was the difference between the predicted price and the actual price considering drift. So this would be the one I would use to tweak the system with. I would use this. The system cannot help drift. So over here is with drift, and error 2 is without drift. So this is more real. And if you're a researcher, this might help you. And then the attribute scoring system based on the composite utility, a forecast of the composite utility scores, was a little bit higher, not much. See, well, actually, overall, the error, yeah, they're just a little bit higher, but just 1% off. We had a couple of them. The one with red, the number 8, that was the highest. So maybe just one wouldn't tell us for sure, but maybe when the property characteristics are not similar, it's going to affect the composite utility score more. Now, this current version does not produce the composite utility score. I'm going to add that in later for the appraisers to use, but it does generate it. Matter of fact, it helps it make the adjustment rates. So these results were under the situation where we used only 5 comparables, and we were searching for 5 different property characteristics, the adjustment rates for 5 different property characteristics. We did provide the land to value ratio because this has to have it, so we had to put it in. Now, if you were using real data, you might not get your ratings correct. One of the advantages that we had here in these scenarios is the ratings are exactly correct. So when we say the condition is a 4, it's a 4, where in the field you might use 3 and be a little bit off. Also, the data, not just the ratings, but the data is accurate. So probably this is better than you would do with real data. Also, this is only a plus or minus 4%. This just shows what happens in that particular random variance of the sales prices at plus or minus 4%. At plus or minus 6 and plus or minus 8%, it's going to be different. I think a lot of the markets that appraisers deal in are up to plus or minus 8%. So also you're going to get into more inefficient markets. So this is still better than I think you would do with real data, but it gives you an idea of what the processor does. And in this case, we didn't help the processor. When you really use this, you would, in the utility sheets, remember, you would put maybe the baths a high and a low to prevent absurdities. And you've seen absurdities with your regression analysis or parking. You could put a high and a low in, and so if the parking is 12, you could say, well, it goes up to 16,000, and then you don't get a 30,000 for parking. So we didn't help it here. And then in the adjustment rates, we didn't do any of these either. Remember, we would look at these adjustment rates, and then we would use the the model monitoring system that we would make changes, and it on the fly would look at 6 different analysis when you change the adjustment rate, whether it helped or it didn't help. So there's a lot of things that you would help that you would use in a real scenario. Now, if you just took the recent seminar, I put on a series of 6 webinars that covered basically the analysis and the evidence in the valuation analysis book that shows that finding sales is it's just not real. It's kind of a snipe hunt. We've been sent off on a snipe hunt, and it's time that we all get our head straight. And when I say we all, the users of appraisals, the appraisers, the reviewers, everybody gets our head straight that trying to extract individual adjustment rates is not any way to prove that you did a credible job, but having these indicators, actual market model indicators that statistically measure, and here I left the system open, let's turn this MMS off, and then these indicators actually tell how good those adjustment rates worked. So if you're interested, if you took the class, you need to get this new version. This new version is version 5, and it's the 4th of July version. It is much more accurate than the previous version. So if you have a previous version of this that you're using, be sure to email me to get an update. If you have never used it or never seen this and would like to get a free copy to use, and I'll send you a link to download a free copy, the user manual, and a startup video. And keep in mind, I believe utilities may show it. This will run until 1/10 of 24. Yeah, till January of 24. So it will run for several months. I intend this to be free for fee appraisers to use for a long time. So if you have any questions or interest, please contact me at my email here. Thanks for watching.